So things change a little bit with our sine and cosine function if we change the period. That is, if we change how long it takes us for us to complete a cycle. And the way that's changed is if we multiply the x value by some number b prior to taking the sine or cosine of it. And the formula for doing that is 2 pi over b. So if we want to think about how this works, let me run through the example. Let's say we've got y equals sine of 2 times x. In this case, we're saying that b is equal to 2. And so our period, the new period of this function, is going to equal 2 pi divided by 2, which is to say our period is going to be pi. Now, what does that mean? What that means is that one cycle, if we started at 0, will end at pi. And as in our earlier graphs, each of the key points were oriented at 1/4 of the period apart. So what we're going to do is this. We're going to take 1/4 of that period, so multiply by 1/4. 1/4 times pi. Well, that's easy enough. That's pi over 4. Each of our key points are going to be that far apart. So in other words, what we're going to do is we're going to take the basic period, whatever it is, divide it, multiply it by 1/4 to get 1/4 of the period. And you notice we're going to go starting at 0, 1/4 of the period. So we're going to add pi over 4 each time to get a new point, right? So 0 plus pi over 4, that's pi over 4. If we take pi over 4 plus pi over 4 again, we're going to get pi over 2. If we take pi over 2 plus pi over 4, we're going to get 3 pi over 4. And finally, if we take pi over 4 and add it to 3 pi over 4, we get pi, which is the end of our period here. Well, that's good, because now we can map out those key points along our x-axis as we would have before. So when I map those out along my x-axis right here, I wonder, well, what's going to happen with the y's? Well, nothing, right? We've got 1 times whatever we would get from sine of 2x. So what's going to happen right here is that we're going to get our y values for this sine function that goes 0, 1, 0, -1, and 0. Just like as in our original function chart right here, right? This is 1 times sine of x. So this is 1 times sine of 2x. So if we map these points here, we're going to start at 0, 0. We're going to get pi over 4, 1. We're going to get pi over 2, 0. 3 pi over 4, -1. And pi, we're back to 0. So one cycle of the function looks probably pretty similar to this. Now, if we continue to follow this around, actually, we can see another interesting thing that's going to happen right here. Prior to this, when we had just one cycle within this 0 to 2 pi, we might have only seen one cycle. Now I'm fitting 2 cycles in for the price of 1. So that 2 that's in front of the x, maybe another way of thinking about a period change, is that for a change in the period for a function, it looks like we're taking whatever the original function might have looked like, the original sine function, which probably is similar to this, and instead of just getting 1 full cycle for that, we're getting 2 full cycles for the price of 1. So you can another way of thinking about this period idea is that our period is related to the original period by 2 pi over b, by that b value. Otherwise, the same features for our graph apply. Our amplitude is 1 right here. Our period, well, now instead of being 2 pi, it's equal to pi. Our domain is still all real numbers, and our range is still, as in our original graph, from -1 to +1. So this is going to be useful for us.